Hello students, this is Coach Holliday, and today we're going to start our unit on inequalities. Go ahead and take out your notes packet and turn it to section 2-1, Writing and Graphing Inequalities. While you're doing that, pause the video and then go ahead and start it back up when you get ready. Now we're going to take good thorough notes on this, so go ahead and follow along with me. We're going to start this lesson with talking about a solution again. If you'll remember, if I gave you an equation that said x equals 2, the solutions of this equation are any number that I can put in place of the x that make this a true statement. And we know that the only thing that makes this a true statement is if I put in the number 2. So if I put in 2, that makes it a true statement. Well, with an inequality, if I change this inequality and make it like x is less than 2, and I want to find the solution or solutions, I want to find the numbers that make this a true statement when I substitute them in for x. So let's think of some numbers that are less than 2. Alright, well, you should think of 1. 1 is less than 2, so that's the solution. 1 is. 0 is less than 2, that's a solution. -8 is less than 2, so that's a solution. So if you'll notice, there's 3 solutions we found easier. As a matter of fact, if I look at 2 on my number line, I'm going to go down here where example 2 is. If I look at where 2 is on my number line, any number that's to the left of this is a solution. All these numbers down here make it true. So it would be any number that goes to the left of 2. Now, does it include 2? Is 2 less than 2? And that's no, it's not. 2 is not less than itself. So I don't include 2, but I include any number that's to the left. So therefore, I have to put an end mark here, and the way I put an end mark there is I'm going to make a circle that's open in the middle. Alright, if it's open in the middle, it means it doesn't include that number as a solution. Okay, so that's going to answer our first part over here. If the inequality is less than or greater than, it doesn't have an equal, we're going to use an open point on the number line or graph. If the inequality is less than or greater than equal to, so what if I change this with the 2 into a less than or equal? Now 2 becomes a solution, so I have to include that in my solution, so I'll put a dot there, and I'll show that it's a solution with a solid dot. So if the inequality is less than or equal to or greater than or equal to, we use a closed point on the number line or graph. Closed, I mean shaded, okay, or filled in. Okay, now next thing is let's go ahead and look at some examples. Okay, in our first problem, our first example, example 1, we want to write the inequality from the graph over here on the right. Now if you'll notice, it has an open dot. I know it's red, but the red just means it's open in the inside. So it has an open dot, so that means it does not include -3. In my solutions, but -3 is the cutoff point. So -3 is going to be the number I'm going to use when I write my inequality. Now I'm going to put an X down, and I need to put either greater than or less than. Alright, so what numbers are solutions to this? Well, if I look at their numbers to the right over here, all the shaded part is over to the right. So the right is solutions, and those numbers are all bigger than -3, because as I go to the right on my number line, my numbers get bigger. Okay, so it would be x would be greater than 3. It does not include 3 because it has an open dot, so I don't use the equal part in it. Okay. Now the second part of my problem is 3 a solution. Well, if I look, 3 is in the shaded area, so yes, it would be a solution. Okay? Alright, let's look at example 2 now. It says to graph the inequality x is less than -2. Now if you'll notice, it does not have a closed dot. It doesn't have an equal in there, so it's going to be an open dot. And it's going to be an open dot at -2. So I'll go to -2 and I'll put an open dot. Now it says x is less than -2. So where are solutions? What are some solutions that are less than -2? Well, if I go to 0, 0 is on the right side, so that number's got to be greater than -2. The numbers that are less than -2 are -3, -4, -5, -6, -7, and so on. So I'm going to shade to the left on this one, and then make sure we fill in our arrow at the end to show that it keeps going, because any number down the number line to the left is going to be a solution. Okay. Now the next part says, is 3 a solution? So I go on my number line, I look at 3. There's 3. Is that a solution? Well, it's to the right of -2, not the left, so it is not a solution. Okay. All right. So those are some basic, simple things about facts about inequalities. The next thing is we're going to look at translating verbal phrases. Okay, now, so in this example, example 3, we're going to translate the verbal phrase into an inequality, and then we're going to graph it. The verbal phrase is a cat can have up to 8 kittens. Up to 8. So let's think about up to 8. When I say up to 8, am I talking more than or less than? Well, if we think about it, when I say up to 8 kittens, could the cat have 0 kittens? 1, 2, that's all true. When I say up to, is 9 included? And it's not. So I'm going to find on my number line where the 8 is. It does include 8 because a cat can have 8. So will that, and the up to is I'm going to go to the left. So I'm going to shade to the left. So the inequality then is going to be x, and I'm going to have 8. And since it can include the 8, I know it's going to have the equal in it. And the solutions are less than 8. They're numbers to the left of it. So I'm going to go there. Okay, so I'm going to write x is less than or equal to 8. And I'm going to graph it that way. Okay, so this is just an introduction. You'll have some of these problems to work in class. Make sure that you complete your WISC, and we'll see you in class